So it's good to be here. It's good to see you all here in this room. My name is Tito, Satria, Putra, Perdan. It's a very long name, right? And I promise that my presentation will be as interesting as my name. So today I'm going to present about overcoming subsurface challenges in Taiwanese geothermal fields. We're going to explore some best practices in geothermal exploration, as well as discuss process solutions that can be applied effectively in Taiwan. All right. So as we delve into this interesting topic, this is the roadmap of our journey together for the next 20 minutes. First, I will give you an introduction about the geologic setting of Taiwan. This is very important. So then you can understand why Taiwan is very complex geologically. Right? The next one is the Taiwan geothermal landscape, what's going on right now. Right? And then we will talk about subsurface challenges that are present in Taiwan. The next one is I will outline the objective of my presentation, setting up stage for our discussion. And then this is important, we are going to show you our assessment of current exploration method in Taiwan, what is lacking, and what are opportunities for improvement. And then the next one is examples of comprehensive and integrated exploration activities, one from Taiwan, of course, and one from Indonesia, my homeland. And the last one is conclusions. All right, so let's talk about geology. So Taiwan, of course, all we know that Taiwan is geologically very, very complex, right? Why? Because it is located along the Pacific Ring of Fire. It is also located on a convergent and present boundary between the Philippine Sea Plate and Eurasian Plate. So the collision between these plates, results in frequent earthquakes, right? Structural complexity, and also explains the presence of volcanoes, mountain ranges, large plains. One of them is Yilan Plain right here, the one that we are going to visit this afternoon, and also hydrothermal areas. And largely, as a result of volcanic and tectonic activities, Taiwan possesses substantial reserves of geothermal energy. And this is what's going on in Taiwan right now. So basically, we have three types of geothermal setting in Taiwan, right? One is magmatic volcanic type, mainly here in the north, called TVG or Tatun Volcano Group. That's about 10 kilometers north of Taipei. It is a large area, about 400 square kilometers, and it has at least 20 volcanoes inside the area. The next one, you go to this part, it's called extensional domain type. One of the evidences is the development of Yilan Plain, one of the major plains in Taiwan, right? So we have three fields. We have Jingshui, Jiangxi, and Tuchang. And if we go down to the southeast of Taiwan, we have 5 fields that have been explored. Huishui, Hongye, Jiban, Jinban, and Jinlu, right? This area here is purely compressional. So that's why tectonically, all of them are very, very complex. So far, there is one project that is active in Tatun. There's 1 megawatt pilot project that belongs to Fabulous Group. There's another project in Jingshui, right? It's about 4.9 megawatt, also belongs to Fabulous Group. And also there is a 850 kilowatt geothermal power plant unit in Jiangxi that belongs to High Power. And in the southeast, we have a small project in Jiban and about 500 kilowatt project in Jinlu. Each of these fields is very unique. They have their own challenges. But all of them share one common problem, one common challenge. And what is it? Finding permeability. In every field in Taiwan, the problem is the same, finding permeability. Where is my permeable structures? Where is my permeable soil? So that has been a big challenge in Taiwan. So that's why all the exploration in Taiwan have focused on answering this question. Where is my permeability? Right? So that's why the objective of my presentation today is, number one, is to improve exploration methods to identify permeable zones and permeable structures in the complex geology of Taiwan. And then, of course, the next one is to showcase examples of comprehensive and integrated exploration activities from Taiwan and from Indonesia, my homeland. All right, so this is our assessment of current methods in Taiwan for exploration. This is based on our experience in Taiwan for more than 40 years, right? We have been providing services since 1980s. All right, so number one is developing comprehensive and detailed geological maps and cross-sections is very important. Unfortunately, some of the fields in Taiwan, they do not have a good, comprehensive, and detailed geologic map. So usually a good map, good geologic map and cross-section include, all of the lithology, structural, right? The location of thermal manifestations, locations of all wells that have been drilled in the area, road access to the area. So because with that, it will help us to understand the local geologic setting of the area, which is very important to answer our question, where is the permeable zone or structure? The next one is, of course, enhance geophysical studies through integrated planning and execution. What we observe in Taiwan is there is lacking of cohesive planning and also execution when it comes to geophysical studies. So mainly geophysical studies are conducted by different parties, using different tools, different equipment, and covering different areas. So there's no integrated effort, and this will increase the uncertainties of our interpretation, right? So that is something that is lacking and we need to improve. The next one is development of integrated geophysical model. So we have gravity, we have MT, we have magnetic, and EQ. Let's try to integrate them, process them together, joint inversion, interpret them together, right? To decrease all the discrepancies and also to have a good alignment across all of the studies. Then the next one, of course, we want to integrate all the data, geophysical, geology, geochemical, right? Through joint interpretation to support geothermal conceptual model development. This is also something that is lacking in some of the fields in Taiwan. Because good conceptual model will provide us with more confidence when we want to put our well, right? And after that, after we have a good conceptual model, then we need to test that. Don't stop there. We need to test that. Of course, we're drilling well, right? If the data of the well support our interpretation, that's good. If there is disagreement, then we need to update and refine our conceptual model using new data. So this is the key. We integrate, we test, and then we improve, modify. Again, we integrate all of the data, we test them by drilling, and we update or we improve our conceptual model. Again, to answer that question, where is my permeable structure zone, where is my reservoir, etc., etc. Right? Okay, so I have two examples. One is from Indonesia. It's called Putra Geothermal field in Sumatra. It's located in the southwest of Sumatra Island. So now it's at the final stage of development. It's 2 times 55 megawatt. It's a quite big field. Right? This area is located in a very complex area. It's not just compression, but there's also big fault, crossing the field, the Sumatra fault zone, right? So permeability in that area is also associated with fractures and faults. So to understand the development of those structures is very important. And then the good thing is exploration activities were strategically planned and assessed during integrated approaches, using integrated approaches. I'll show you examples of that. And then borehole images. So they also collect many well data, usually borehole images, to understand development fractures and faults in the subsurface, and then they try to tie with the surface map, right? And then after that, the conceptual model of the resource has been consistently tested and refined with the acquisition of new data. They have been doing this study since 1970s, you know, and they always update the conceptual model once the new data are coming in, you know. And then these evolving models has guided them, you know, well targeting and also field development strategies, where to put your production, where to put your injection wells, right? And you know, where to drill next, etc. Okay, this is the map, geologic map. It's very detailed, as you can see here. All the faults are mapped and named, right? All the lithology is carefully mapped as well, right? All the thermal manifestations are placed on the map. You know, they're like a nice correlation. We can see that some of the manifestations are associated with faults. You know, so from this one we can see that okay, there's actually a good relationship between your structure and your thermal manifestations. They also established this good stratigraphic column to understand age and also the relationship between rocks in the map. And then here they also create a very good geologic cross-section. Not just from surface data, as you can see, there are about 21 wells. They use each well data to create this cross-section. And this has improved the drilling success rate in the field quite significantly, right? The next one, not just that, you know, so structural map from the surface, they also try to test that using borehole image from all the wells. Try to understand, do they show a good agreement, you know, from the surface and subsurface, right? What is missing? But overall, there is a good agreement between subsurface data and surface data, right? They also run an EQ to understand the which fault is active, right? So as you can see here, there are some micro-earthquake events that are associated with this fault here. And mainly, you know, the production is tapping this fault rate, which agrees with what MEQ tells us. This is gravity data, as you can see. This is a low density anomaly that is associated with fracture development, right, from surface data. And what happened is, actually, this is proven by drilling. So everything here is the reservoir, right? Empty data also show the same thing, same kind of shape, you know. This is a moderate resistivity anomaly, just represent this zone right here, which is your reservoir. So MAQ, geology, gravity, empty, they show the same thing. We integrate them, we get more scoring, you know, we get more confirmation, right? Our confidence level is increasing significantly. So by that, they can develop this very good and very comprehensive geothermal conceptual model, right? Where's the upflow zone, where's the reservoir zone, which part of the zone is hot, which part of the zone is not hot, right? So where to put your wells, production, injection, etc. So this is one of the best examples, right, from blue-light geothermal. The next one is, of course, from Taiwan, from Putra. This map is created by CPC. It's quite detailed. There are some geologists in CPC that are, you know, mastering in, you know, geological mapping of Taiwan. You know, those guys mapping the Tatun, Tuchan, Renze, right? These are quite good area as well, quite good map, you know. Good faults, information, you know, thermal manifestations, well locations, right? Different fracture zones, right? Lithology, and as you know here, they also run FMI data of some of the wells. You know, just want to confirm whether what they see on the surface is supported with what they see in the subsurface. And the result is quite good. that what they observe in the subsurface support with what they observe in the surface. Right? There's a good correlation between the fault development here in the subsurface with the fault development on the surface. And even here, we could put a major fault zone based on subsurface data, which actually correlated to one of the faults here on the surface. And that fault is one of the major faults, that associated with the good reservoir and permeability. All right, T. So the conclusion, number one, Taiwan is situated within a structurally complex geological region. All know that. The challenge is, to identify permeable structure and zone, and it's the complex setting. And there are significant opportunities for growth and improvement in understanding the geological context and its link to permeability, as I mentioned earlier. And then exploration activities should be strategically planned and evaluated through integrated approaches. And exploration results will contribute to developing a robust conceptual model, which must be tested and continuously refined. Again, integrate, test, improve. Integrate all the data, test that by drilling, and improve our conceptual model. That's all from me. Thank you.